Okay, what's the next one we need to do? 2 and 5? 2 and 5. Okay, so let's see. Trenton, rows 2 and 5. How many ways would there be?
5.
You're getting 5. So you take this x with this one with either of these two, and this one with either of these two. Yeah, 5 looks right to me. Okay, rows 3 and 4. Belize, can you help me with rows 3 and 4?
No, 3.
Just 2, right? You take this x, and then you take either of these two x's here. So that's a total of 2. Okay, rows 3 and 5. Adriana, rows 3 and 5. How many ways are there to choose x's in rows 3 and 5? 2 ways. Yes, that sounds good to me. And rows 4 and 5. Peter. 4 ways to do that one, right? And what does all that add up to?
31.
31?
32.
Uh-oh.
I hope it's 32. It better be 32, because I know that's the answer.
Oh, shoot. Wait. What?
Okay.
Oh,
Guys, if you added that up wrong and got 31, I'd probably give you full credit. As long as you have the 10 numbers written down there, I can see, oh, the person just, made a dumb arithmetic error. I don't really care about that. So. But if you don't show your work and you write R2 equals 31, I can't help you. I mean, I basically may have to give you 0 points for it. I have no idea what you know. At least 0 points for that piece of the calculation. All right, R3. How many terms will there be for R3?
5 choose
5 choose 3, which is
10.
10. 10 terms, right? All right, so tell me which row combinations we have to look at. What would be the first one? 1, 2, 3, and the next one? 1, 2, 4, next one? 1, 2, 5, next one? 1, 3, 4, next one? 1, 3, 5, next one? 1, 4, 5, next one? Okay, next one? Next one? Okay? And 3, 4, 5 is the last one, right? So we have 10 of those. So we have to add up 10 more numbers. Okay? And this gets tricky, so you're going to do the first 3 rows together. We have 10 people here, right? So we can all do this together again. Jessica, I'm going to make you our first contestant here. Rows 1, 2, and 3. Can you tell me how many ways there are to choose x's?
2.
2, okay? Let's see. That's not what I got.
It's 1. Wait. 1. 1.
Say 1.
1.
1, perfect, yes. Because you have to pick this x.
Yeah.
There's no choice about that. And as soon as you do that, then up in the first row, you must pick this x.
Yeah.
Which means then in the second row, you must pick this x. It's sort of a domino effect of restrictions. There's only one way to do that. Okay?
Is it better to go 1x to 2x to 3x?
If possible, start with the rows that have less x's, because there's less choices. Yeah. Okay, Elizabeth, how about rows 1, 2, and 4? And everybody can be doing this, so that we can check answers here. See, with rows 1, 2, and 4, you almost have to do a couple of cases. Right? One case is you chose the upper left corner x. And then in rows 2, if I choose that x that's blue, and I now look at rows 2 and 4, I really have just these 2 x's and these 2 x's. How many ways are there to choose from these 2 and these 2? Say again? 3?
Can you repeat it?
Well, if I choose this x, I'm just asking how many ways are there to choose x's from rows 2 and 4 here. I can't pick this x, but I have two x's here and 2 x's here. Well, wait a minute. If I pick this x, then I can pick this x. But I could have picked this x, in which case I could pick this x or this x. So that's 3 ways with that x. Plus, we got to do the other x, right? In which case, how many ways are there to now pick x's in rows 2 and 4? If you look at rows 2 and 4, you're not going to look at this column anymore. You're just looking at these two x's and these two x's. No, it's not 1. You have basically this pattern in rows 2 and 4 after you circle this blue x right here. So there's these two and these two. So you can either pick this x with this x with this x, or this x with this x. 3. Right.
There's 6.
Plus the other 3 is 6.
Holy gosh.
Oh my goodness. Okay. How about rows, Lisa, row 1, 2, and 5?
Well, if you choose the first x, then we'll have 2 choices.
If I choose this x, then in rows 2 and
5.
5,
2 choices.
you do?
Yeah.
I don't think so. If I pick this x,
Yeah, then you have 2 choices.
I can pick this or this,
Yeah.
but I can also pick this or this.
No, because that
Well,
x is x'd out.
Oh, that's right. I'm wrong. Excuse me. Can I delete that one? Yeah, no, that's right. I can't pick this x down here. I must pick this x. Thank you very much. And therefore, I have 2 choices here. Okay, perfect.
But if you choose
Oh,
the other x.
Yes, right, the other x. Forgot about that.
But if you choose the other x,
Yeah.
then there are 3 choices.
Then there are 3 choices, right? Because you have these 2 x's and these 2 x's to work with. So that's 3. So 2
there's-
plus 3
Is 5.
5. Thank you. Okay. Let's see. Everybody comfortable with that? All right. Let's go to the next one. 1, 3, and 4. Belize, how about I pick on you for this one? So the rows 1, 3, and 4. How many ways does that do that? Only one way? So I have to pick this x, which means I have to pick this x.
Oh wait, 4, okay, so then, that's 2 choices. I was
2
looking for
choices.
5.
Yeah, 2 choices, right? Okay, so plus 2. It's okay. It's hard to keep this all straight. All right, how about row 1, 3, and 5? Fran, can you help me with that? It's only 1, right? Because you have to pick this x, which means you must pick that x, which means you must pick that x. So I have one way to do that. Okay. Peter, how about rows 1, 4, and 5? The first row and then the last 2 rows. So for this x, right? 6. Right. For this x, I have 2 choices, right? These 2 here, and I have to pick this one. For this x, I have these 2 and these 2 gives me 4 combinations. So 2 plus 4, that's 6 ways. Everybody okay with that? That's for rows 1, 4, and 5. Okay. Adriana, can you help me with rows 2, 3, and 4? So for 2, 3, and 4, I have to pick this x, which means I'm not going to pick this one. So in rows 2 and 4, I've got these 2 and these 2. Right? So for this x, I would have 2 choices. For this x, I only have 1 choice. So it adds up to 3. Is it 3? 3 sound good? Okay, good. 3. All right, and rows 2, 3, and 5. Trenton, let me pick on you. 2, 3, 5. Four ways? Anybody else get 4? So a lot of people say 3. If you pick this x, then you have these 2 x's together with these 2 x's, right? So again, when you have this pattern that looks something like this, where there's 2 above each other and then 2 that are not above each other, it's always going to be 3. Because you can pick this one with this one, or this one with either of these 2. So that's 3. All right, that's for 2, 3, and 5. Okay, Jeff, how about 2, 4, and 5? Oh, you've already got it. 8. 8 ways is a lot of ways. Let's see, 2, 4, and 5. If I pick this x, then I've got 2 ways, right? If I pick this x, well then I have to pick this x. So I have 2 more ways. That's 4 so far. If I pick this x, Then I got both of these with both of these, and they're all in different columns, that's 4 ways. So 2 plus 2 plus 4, right? That's 8. And finally, oh, I haven't done one yet. I'll do this one. So, because I think everybody's done one. This x with either of these, that's 4. That's easy. That's an easy one for myself. Okay, what's that add up to?
39.
Excellent. That's what I got. All right. Moving right along. R4. How many terms will there be? 5 terms. Okay. And what are the row combinations that give me those 5 terms? Okay, you can think about which number you're leaving out. Okay. I again want to put them in a logical order. So 1, 2, 3, 4. 1, 2, 3, 5. 1, 3, 4, 5. No, 1, 2, 4, 5. Excuse me. 1, 2, 4, 5, and then 1, 3, 4, 5, and then 2, 3, 4, 5. Those are my terms. Clear enough? So I have to do 5 terms here. So rows 1, 2, 3, and 4. Now these numbers should be a little smaller because we've got a lot of constraints. So with row 3 involved, I have to pick that x, which then forces me to pick that x, which means I now must pick that x, which means I must pick that x. I was actually able to do it, but there's only one way, right? And now rows 1, 2, 3, and 5, again the 1, 2, 3 is going to give me this, this, and this, and that means I have to pick that x, so I've got only one way to do that. The hard one is going to be the 1, 2, 4, 5, because when you don't have row 3 to work with, it's harder. So, can somebody give me the answer for 1, 2, 4, and 5? We've already got an answer, a proposal of 6. So for this x, then I'm going to have, well, let's see, I can take this one with this one.
Well, if you choose the first x, you have only one choice for.
Oh, so then, yeah, if I choose this x, then I must choose this x, right? And then I'm looking at these two in the middle, and there'll be 3 ways, right?
Yes.
Okay, I like that reasoning. And then on the other hand, I could have picked this x, which means, well, this x with this x, okay, would give me 2 choices here, and I have to pick this one.
The 2.
Or this x with this x.
2.
I have to pick this one, and I have 2 choices here. Is anybody adding this up?
7?
That's 7. And then I've got,
You already did it. You did everything.
I did everything? Oh yeah, I did everything. That's only 7? That's 7? That doesn't sound right. Wait a minute. Wait a minute. Wasn't it 3 ways and 2 ways?
3,
With
2,
this,
2.
with this x, there was
You have to choose the bottom,
this one.
and there's 3 choices between 2 and 4. Because there's
Right, so there's three ways to do, 3 ways with this blue x, and there's 2 ways with that
there's
blue x.
4 ways with that 2x, because you have 2 x's to choose from in the second row. If you choose that first x in the second row, you have 2 choices.
Okay,
And then if you choose the second x, you get 2 choices.
okay, so that's,
4. So 3 plus 4
that
is
adds
7.
up to 7?
Yes.
Oh, what do you know? I have an answer of 7. Oh. Okay.
Algebra is hard.
Okay. How about 1, 3, 4, and 5? I have to pick this x, therefore I have to pick this x,
Therefore you have to pick the x in the
therefore you have to pick this x, so you have 2 choices here. That's easy. Finally, 2, 3, 4, 5. Again, I have to pick this x. Well, I could pick this x, which would mean I'd have to pick this x, I'd have 2 choices here. Or, I could pick this x with this x. And then I'd have to pick this x, and I'd have 2 choices here too. So that would be 4. That's what I got. That is what I got. And that adds up to 15. Finally, what is R5? R5, you know it's at most 1, because row 1, 2, 3, 4 already only had 1 way of doing it. So we can just look at what way did we do that. Well, that was this x with this x with this x with this x, and can I successfully?
Yeah.
Yeah, I can pick this x. So there is a way to do it. This is not blue anymore. There's only one way to do that. Okay? So that's a 1. So, my final answer, 39. 30 minutes later, is 5 factorial minus, what do we have, 10 times 4 factorial, plus 32, thank you, times 3 factorial, minus 39 times 2 factorial, plus 15 times 1 factorial, minus 1 times 0 factorial. And again, you can leave it like that, right? And assuming everything's right, you get full credit. You don't have to simplify it. The reason to simplify it is just if you want to check your work. You have extra time and want to check your work. So these take a little while.
Can this be the whole test?
It's like the whole exam. Huh?
They don't give us a 6x6.
You know what I could do is
Oh,
just
that's
give you a
X's.
6x6 with not very many x's in it.
Like
That
two
would-
X's.
There we go.
There you go.
So how can you determine the number of terms if a row is empty? Do you say like, okay, it's a 6x6, but there's 2 rows empty, so is it 4, choose so many?
You still in theory have 6 choose whatever bar value you're working on. So if it's an R3, it's still 6 choose 3 terms. I can still write down 6 choose 3 ways of doing this. Let's just say it happens to be row 6 that's empty. Then I could write down all 6 choose 3 ways of doing it, which by the way, 6 choose 3 is 20. There'd be 20 terms there. But then any term that includes a 6 on it is going to be a 0, so you don't really need to write it down. So these would be the only ones you would need to actually calculate. The rest of them would be zeros. And if you didn't write down those row combinations that had 6 in them, I would understand that that's what you're doing. You're saying, oh, those rows are empty, so I'm going to get a 0 when I'm creating violations that involve that row, because I can't create a violation in that row.
So 6 choose 3 with 1 empty row is the same as 5 choose 3?
Exactly.
Okay.
Exactly. In terms of how many terms there are.
Yes.
You got it. You got it. Okay. And everybody good on that? You know, I could devise a question where you don't have to do all of these terms, you know, where I just basically pick off, I want you to tell me how many violations are there to John's schedule, Jim's schedule, and Jerry's schedule. I could get like specific and look for isolating something very specific so that you're not good. Because honestly, I'm not interested in having you spend 30 minutes doing this, really. I mean, I want you to understand how to do it, but I don't need to see you do it. How many times did we do it? Like 5 times, 10 more times, 10 more times, 5 more times, 1 more time. That's like 30 some times of you showing me that you know how to do this. That's a little overkill. So, but I might pinpoint a particular term and say, I want to know this term.
If you did it in that way, it would be calculating one of the R's.
Yeah. Or it might even be one of the terms within one of the R's. But I'd have to tell you what I was looking for, what I specifically, which term I wanted. So. Okay. Yeah, I mean, it would be how many ways could the hotel administration schedule people so that Jack, Jerry, and Jim were scheduled at a time that they were unavailable. And it basically is specifically saying how many ways are there to choose X's in those rows specifically. So I could just ask that. And then you'd be looking for like,
145.
you know, that number right there. Yeah. And then, so then I'm only asking you to do it once to come up with that one number. I mean, I don't know. I haven't written the test yet. I'm thinking out loud right now. No idea. Okay, let's move on. I want to get to some other stuff. I think I'll put the next question here. So, have you guys looked at these questions yet? Has anybody looked at these? You just you wanted to be surprised.
Yes.
So, okay, you're going to be surprised. Here's number 7 on the review packet. For M1 and M2 and N greater than or equal to 2, with M1 and M2 at least equal to N, prove that the summation, k going from 1 to n minus 1, of k times n minus k times m1 choose k times m2 choose n minus k is equal to m1 times m2 times m1 plus m2 minus 2 choose n minus 2. And I'm going to give everybody, so if you already know what this is dealing with, give everybody 30 seconds of time to think it through before we come up with the answer. So if you see that kind of question, first thing I want to know is how many people think they know what, just raise your hand, how many people think they know what topic this has to do with, of the stuff we've studied? Like where in the semester is it? Like what chapter is it from, or what homework assignment was this related to, or something like that. So Lisa thinks she knows, nobody else knows? Anything with Adriana knows? Elizabeth? Okay, got a few people. You see, this is what you want to prove, this formula here. I mean, are you, in terms of like, how are you going to do it? Like, does anybody have an idea, like, when I say what topic is this about, I'm sort of asking, do you know how would you start going about the proof? Would you try to add up all these terms, right? Would you write out the factorial expressions of these things? Like, what would you do? Do you know, Peter?
I'm thinking of kind of men and women committee.
So, but what topic is that? Like what, among all the stuff we've talked about, what is that called? A combinatorial proof, right? Yes, we want to give a combinatorial proof of this, which means that we need to come up with something that we can count in two different perspectives. And we're going to count the same thing from two different perspectives. Okay, so then addressing the question of like, what exactly is it that we are going to count, that's a whole nother, that's a whole other issue. So, Jen, so, looking at the terms here, does anybody have a suggestion for what the M1 should represent, or what the M2 should represent, or what the N might represent, or what the K might represent? Any ideas? Lisa?
I was thinking of our committee example, but possibly, like, N could be the total number of people that we have.
Okay, so consider, whoops, this doesn't work. Consider committees. So for the solution here, consider committees. All right. What size committee do you think this might be? Brad? Okay, of size N. What's the total number of people we have? M1 plus M2, and what is that's a breakdown into two parts, so what would you think of as M1 and M2? Men and women, very good. Okay, so consider committees of size N made from a group of M1 men and M2 women, right? That might be a good way to think about it. So, is that all we're doing? Just choosing a committee of M1, of N people from M1 men and M2 women? I mean, if we were doing that, the answer would just be M1 plus M2 choose N. Maybe we should, okay, instead of president and vice president, why don't we say that we're choosing a, right, we're choosing a chairman and a chairwoman or something like that, like two people to lead the group. Okay, yeah, I would think of it that way. So we're not only we're considering committees of size n made from a group of M1 men and M2 women, where a chairman and chairwoman are also selected. So you're not just making the committee, you're specifying leaders from both the men and the women group. So you end up, by the way, you have to have at least one man and at least one woman to do that, which is why over here your summation does not go from 0 to n, because if k is 0, then you're choosing no men. And if k is n, then you're choosing no women. And these committees have to have at least one man and at least one woman if you're choosing one of each to chair the committee. Yeah?
What we're describing right now will end up being the right side, right?
What we're describing right now is we're not on the right side or the left side yet. We're just looking at what is the common thing that we are going to count from two different perspectives. And this is really the hard part, is to see that this is what you want to count. Okay, so we can go and do the right-hand side right now. I'm fine with doing that. So for the right-hand side, you know how we break this down, right? For the right-hand side, so can somebody explain what's happened to give me the number on the right-hand side? Elizabeth.
We choose our chairwoman and chairman first.
Okay, there's those many choices, right? And then what's
Out
left?
of the people that are left, we choose them.
Right, okay, so right-hand side, choose a chairman. And that would be M1 choices for that. And a chairwoman. And that would be M2 choices. And then to complete the committee of size n, we choose n minus 2 more people from the remaining M1 plus M2 minus 2. And the remaining people could be men or women. You don't specify that. We just throw them all together in a pool and choose n minus 2 of them. Okay? On the other hand, for the left-hand side, who thinks they might be able to explain what the left-hand side is doing? Jeff, go ahead.
There are any cases where
Okay.
we choose 1 and 2 all the way to minus 1 men.
Okay.
And then we fill the rest with women. And then from those men, then we choose the chairman, and from the women, then we choose one.
Right, so you choose the two individual groups of people first, and then you select the chairman and the chairwoman second. Whereas up here, see on the right-hand side, we chose the chairman and chairwoman first, and then built the rest of the committee. So you're just doing the process in the reverse order. Okay, so for the left-hand side, begin by choosing K men, and there will be M1 choose K choices for that, and N minus K women, and there will be M2 choose N minus K choices for that. Okay, so choose K men and N minus K women. So you set those people up first, then choose a chairman. That would be K choices. Notice how as I make each choice, I'm explaining how many choices there are. So it'd be K choices to choose a chairman, and then choose a chairwoman. Chairwoman, and for that, there's going to be N minus K choices.